Good morning, everybody. Hope you're doing well. We're going to be starting a new unit today, but since we're doing virtual learning, we're not going to test the old one. You did the review in Delta Math, so we're just going to keep pushing forward. So, your homework tonight will be in Delta Math, and this computer is frozen. That's not fun. There we go. All right. So we're going to be simplifying expressions involving exponents, so a little bit of a review. You've been doing this since 8th grade, so hopefully this looks familiar. And as we know, repeated multiplication and division is represented by exponents. So let's begin. If we look at something like 6 cubed, if I wanted to break that apart, that would be 6 times 6 times 6. But writing all of that's kind of annoying, so that's why this exponent notation is very helpful. It's really like 6 to the first, 6 to the first, 6 to the first, which is 6 to the 1 plus 1 plus 1, which is how we got our 6 cubed. And then if I was going to use it to evaluate, so if I have f of x equals 2x cubed plus 7, and I want to find f of negative 1, as we've seen before, we just substitute in negative 1 for our x. And that cubed is only attached to the negative 1. So this really, if I was going to break this apart, would be 2 times negative 1 times negative 1 times negative 1. And then that plus 7 off to the side. And negative 1 times negative 1 is positive 1, but then we're multiplying by another negative 1. So we really have 2 times negative 1 plus 7. I'm just going to scooch this up here. So then we have f of negative 1 is negative 2 plus 7. Oops. So therefore, we are left with a value of f of 1 equals 5. And as we've shown in previous units, this really is like an xy point of negative 1, 5. I probably should have mentioned this at the beginning. If you didn't print this notes out, which is totally fine because I don't expect you to, you can just write the examples down on your separate paper like you were doing the past previous weeks. And if you need me to slow down, just let me know. Or if you're watching the recording of this, you can just pause the video whenever is useful for you. So let's deal with a little bit more of an algebraic example now. If x cubed times x to the 5th is written in some form x to the n, so n being some exponent, what would that exponent be? So just like above in the previous example, when your base was the same, we added the exponents. So x cubed times x to the 5th is really x to the 3 plus 5, which would give us a value of 8. So therefore, the n value, the exponent value, is 8. Okay. Next is if an expression 5x cubed all squared is written in the form ab to the x, what is a plus b? So remember when we have a power to a power, we could expand it, but then you might recall the shortcut. So we have 5x cubed, and since it's squared, I'm going to write it out twice. And then if I was to break this up even farther, it's really like my 5's are being multiplied together, and my cubes are being multiplied together. So we really have 25x to the 6, because a 3 and the 3 is going to give me a 6. So it says it was ax to the b power. So they're just trying to confuse you with some more variables. So I'm just going to rewrite that below. So I had 25x to the 6, my real life answer, and then they said if it's an ax to the b form, we got to first know what is a representing and what is b representing. So based on this, our a is equal to 25, And our b is in the spot where the exponent is. So that is equal to 6. Oops, my page is scrolling on me. So then if I do a plus b, I'm really doing 25 plus 6, which is equal to 31. So just another fun way to kind of manipulate those numbers. So I'll give you a moment to write that down. All right. Scientific notation. You did a lot of this in 8th grade. It was probably like the big chunk of the fall semester of your 8th grade year. So it says we have a rectangle. Oops. And its dimensions is 3 times 10 to the 5th and 2 times 10 to the 4th. Now, normally we don't like x's in our problems, but it did specify scientific notation, so in this case, it's okay. It says, what is the area? Written in scientific notation. Well, we know that area of a rectangle is our length times our width. So what we're doing here is we have our two, I thought I changed colors. Guess I didn't. Is 2 times 10 to the 4th times 3 times 10 to the 5th. And we can organize it just like we did problem letter, what was that, D. So my real life numbers, my 2 and my 3 get multiplied together. Oops. And I'm going to do my 10 raised to some exponents, so 10 to the 4th times 10 to the 5th, bundled together. So 2 times 3 is 6. And I keep my base, but I add my exponents. So 4 plus 5 is 9. And of course, can't forget my unit of measure. It did specify it was meters. So since it's area, it's going to be meters squared. I should say A equals. Trying to be a little bit more precise with my work. Okay. It says rewrite the product as an equivalent expression in simplest exponential form. So 3x squared, the whole thing is being squared, so I'm going to write that out twice. So 3x squared times 3x squared. And then 2x to the 5th is being cubed, so I'm going to write that out 3 times. So 2x to the 5th times 2x to the 5th times 2x to the 5th. And then if you want, we can group our numbers and our variables together just to make it look a little bit more organized. So we have 3 times 3 times 2 times 2 times 2. And then I have an x squared, an x squared, x to the 5th, x to the 5th, x to the 5th. So if I have 3 times 3 times 2 times 2 times 2, that's going to give me a value of 72. And then I'm going to keep my base the same. X isn't going to change, but my exponent will. So I have a 2 plus a 2 plus a 5 plus a 5 plus a 5. All of those added together will give me 19. So 72 x to the 19th would be your final answer for that. Okay. So that's with multiplication. But let's think of division now. So if with multiplying, we were adding our exponents, that means with dividing, we're going to be subtracting our exponents. So it says, consider the following expression, 2x to the 6th divided by 4x squared. There's a couple ways to look at this. It says, write the expression as a product of two fractions, one of which is equal to 1. So if something's equal to 1, it means it's the same number divided by itself. So like 5 divided by 5 is 1. 10 divided by 10 is 1. X divided by x is 1. So as long as your numerator and your denominator are exactly the same, it will simplify out to 1. So we're saying we can break apart this numerator. And we can break apart our denominator. So if I wanted to break apart 2x to the 6th and 4x squared, I'll just rewrite those originals. If my pen wants to work, that would be cool. Whee, it's frozen. There we go. There's all my doodles. All right, so we have 2x to the 6th over 4x squared. Another way we could rewrite this is I want the top and the bottom to be the same, so I need to find the GCF. So I could have, they both have 2 in common. And the most I can take out of each is a squared, but then the leftover would be an x to the 4th on top and a 2 on the bottom. So I can see that this cancels out into a 1, so I'm really left with x to the 4th over 2. Now, if you're thinking like, I don't like that method, which is totally fine, to each their own, there's another way we could simplify this. And it's the way that I showed you in class earlier in the year. So I'm just going to rewrite that original again. Now with dividing, a lot of you found it really helpful if you expanded out those numerators. So we have 2 times, and if I have x to the 6th, that means I have 6 of them. So I have 1, 2, 3, 4, 5, 6. And then on the bottom, 4 can be broken up into 2 times 2. And then x squared means I have an x and an x. And then we can just look to see what is the same on the top and the bottom. And that is going to be what gets crossed off. Let me make my highlighter a little smaller. There we go. So that gets crossed off. That gets crossed off. And now I'm just going to rewrite what's left over. So on top I have x, 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 x. That's 4 of them. And then on the bottom is just a 2. So personally for me, I like that way a little bit nicer. We just cross out all the ones. Maybe a little bit more work, but to each their own. Whatever method works for you is fine with me. So let's try a couple more examples on the back or on the next page, depending on how you printed this, if you did. So example A is just dealing with a regular base of 5. So if I was to expand this out, 5 to the 7th, that means I have 7 of them. So 1, 2, 3, 4, 5, 6, 7. All over 5 cubed would be 3 of them. So 1, 2, 3. And now I'm just going to cross off what's the same on the top and the bottom. So I've got a pair there, a pair there, and a pair there. So we see we have 4 of them left, so that's really 5 to the 4th. Now some of you might be like, well, can I just subtract the exponents? Absolutely. 7 minus 3 is 4. I'm totally fine if you do it that way. Where you got to be careful though is if you have more, if you have a higher exponent in the denominator. You got to be careful of that. Which, coincidentally, is our next example. So I'm just going to expand it out. So I have 4 x's on the top. And I have 10 on the bottom. This is where sometimes the expanding method can be a little bit longer, but it will ensure you a correct answer. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we've got it expanded out, and I'm going to simplify through. So all those cancel out. Now, I don't technically have anything left on top, so there's really a 1 there. So technically there is something left. It's a 1, just not an x anymore. And then on the bottom, I have 1, 2, 3, 4, 5, 6 x's left. So 1 over x to the 6th would be the correct answer for that one. Now, if you were subtracting this, if you would have done x to the 4 minus 10, you would have gotten x to the negative 6. And we can't have negative exponents. It's not allowed. So if you remember the rule, you'd have to switch them to be 1 over. That would have to come down to the denominator. So 1 over x to the 6. So no matter which way you choose to solve it, you'll get the same answer. It's just whatever method works for you. Scooching over to our next example. So this one has more than one variable, but we're still going to solve it the same way. So I have 4 x's, 1, 2, 3, 4. And then I have 8 y's, 1, 2, 3, 4, 5, 6, 7, 8. All over 1x and 10 y's. 10. Whew. Okay. And then we're just going to simplify out. So we have a pair of x's that cancel out. 1, 2, 3, 4, 5, 6, 7, 8 y's that cancel out. And then whatever I didn't cross out, that's what's going to be our answer. So I have 3 x's on the top, which means I have an x cubed. And I have 2 y's on the bottom, so a y squared. If you were going to subtract these, you would just take your variables and break them up. So that would be like x to the 4 minus, now there's technically a 1 there. And you'd have y to the 8 minus 10. So you would still get x cubed, but y to the negative 2. And of course you can't have a negative exponent, so that y, the negative 2, would have been moved to the bottom. So you would still get x cubed over y squared. And again, it's whatever method makes the most sense for you. I do not mind whichever. So we'll do a couple more examples and then we'll call it a day. All right, so these have a little bit more meat to their bones. So before I'm going to just simplify out numerator and denominator, I need to simplify that numerator first, because I have a power to a power there. So I really have 3x squared times 3x squared times another 3x squared. And my denominator is not going to simplify yet, so we're just going to bring it down for the journey. We can simplify that numerator now. I have a 3 times a 3 times a 3. So that's going to give us 27. And then I have x squared, x squared, x squared. That'll give us x to the 6th over 9x to the 4th. And then here, now we can start breaking this apart to simplify. So, I'll change colors for the occasion. So if we want, I'm going to break that up into primes just so I can see it cancel out a little bit easier. X to the 6 means I have 6 of them. So 1, 2, 3, 4, 5, 6. All over 3 times 3, and then 4 of those. So I guess I didn't, if I'm going to do this expanding approach, I guess I didn't have to multiply all those through. I could have just written it out in expanded form right away. But it just, you know, whatever method you pick. So I have 2 pairs of 3's that cancel out. I should use a darker green. It's not showing up very well. There we go. And then I have 1, 2, 3, 4 x's that cancel out. So let's see what's remaining. I have a 3x squared on top. My pen froze again. Still frozen. Maybe it died. Oh, there it goes. All right. Over 1, but anything divided by 1 is just itself, so we can leave this as 3x squared. If you were doing it a shorter way, you could have just asked yourself, what is 27 divided by 9? Well, that's 3. and then x to the 4th, excuse me, x to the 6th over x to the 4th. Well, 6 minus 4 is 2. So again, definitely another shorter way to do it, but I'm just going to expand it out for your notes. Okay, one more example. All right, so we have 5x squared y cubed all squared, and then the denominator is also the whole thing squared. So I'm just going to expand it out right away. If you want to simplify it and do it another version, you're welcome to. So I have a 5 and a 5. I have an x squared and an x squared and a y cubed and a y cubed. So I had to double all of those, and same with the bottom. I'm going to have a 10 and a 10, an x and an x, a y and a y. And if I want to break that up even farther, I can. I need some more space. So I have 5 times 5. And then if I have squared and squared, that means I have 4 of those. So 1, 2, 3, 4. And if I have a cubed and a cubed, that means I have 6 of those. So 1, 2, 3, 4, 5, 6. All over. 10 can be broken up into 2 times 5. So I have a 2 times 5 and a 2 times 5. So 2 times 2 times 5 times 5. And then its variables are already broken up for us. And now we can do a bunch of simplifying. So my 5's cancel out. I've got 2 y's that are going to cancel out. And I've got 2 x's that are going to cancel out. So when the dust settles, let's see what we got. We got x and x on the top, so that's x squared. We have 4 y's, so that's y to the 4th. All over, it looks like we only have 2 times 2 on the denominator, so that would be a 4. Awesome. So that's all I'm going to do with you guys for today. And again, there are shorter methods to solving these, but expanding it out may be a little bit more work, but it's nicer to see everything simplifying out. So I hope you have a great day. Let me know if you have any questions. And there's still a few of you that need to submit your Silver Linings Flipgrid to me, so look for that post in our Microsoft Teams. So have a great